Hello and welcome, everybody. We're just going to give about 20 to 30 seconds for everyone to join, navigate their way through Goldcast, and get comfortable for the next 30 minutes. Thanks for those that already joined on time as well. Looks like we're going to have a great session today. Fantastic. All right. So thank you, everybody, for joining us today. My name's Nathan Stevens. I look after the solution engineering team here in APAC. And joining me today from the start of the session is Mr. Denny Jury, who heads up our solution architecture space for FinOps. Welcome, Denny.
Thank you very much, Nathan.
So today we're going to focus a little bit more, go fairly specific down the rabbit hole, so to speak, on data cloud optimization or data cloud platform, as it's known, or data platform, depending on which piece of literature you actually are reading. So Denny's going to join me. We're going to talk throughout the session today, and it'd be great as well if you have any questions. As usual, please put them in the Q&A chat. If you go into the messages, we'll try to manage both of those, and Ash in the background will help navigate some of the questions that do come through, as well as this will be recorded. So if you do want to share this with colleagues after the event, it is recorded for their viewing pleasure. All right, so just to recap, since last year, moving into this year now, we have done 7 of these great webinar series. So we're running out of room on this slide to give a bit of a summary of each of these, but Ash will put in a second some links to the all of these, so you can watch them on replay, on demand, for in case you've missed any of these in the past 7 months. So we're going to keep on going, and into the next few months, we're going to start to look towards these 3 topics. So obviously for today, we're going to focus in on data cloud optimization. So what we're doing here today is really looking at how we manage or costs, particularly around Databricks, and we'll touch a little bit on Snowflake, but also talk about data cloud in general. Start to look at some of the ability to optimize, the differences in the data cloud space compared to sort of the traditional VMs and in FinOps practice. Next month, we take a bit of a pivot back into a very traditional subject around IBM audit readiness. So there's going to be a great look at what happens when you get the audit letters and what you need to do, and some of the tips and tricks around being prepared for an IBM audit and how Flexera can help there. And in May, we're going to take the journey to proving ITAM value. So we'll be joined from some other members of our team as well, looking at how do we actually get the metrics and the KPIs in ITAM and translate them into business outcome language and leadership level language to prove the value of ITAM, something that a lot of us struggle with in converting that language into leadership executive level talk. So a fantastic opportunity to join us on the 20th of May as well. All right, so just as we start each, just to position us where we are in the market today, and data cloud is no different amongst this as well. So when we start to look at spend is increasing across the board. This is no different from the cloud space, 47% increase in the last 3 years, SaaS at 51%, and also moving into the global AI spend as well. So which is becoming has become a $644 billion industry. We're at this, tipping point, this analogy here that we're beyond that point now where a lot of this spend needs to be proactively managed and managed well. If we start to look at pushing more and more workloads into the cloud, and today talking about that data cloud space, this is also contributing to driving up this spend in cloud. As you move from the traditional on-premise compute, on-premise data warehouse technologies into the newer technologies that have really, exploded over the last few years in particular. Now, as we take a look into our platform, for each of the topics, we sort of try to narrow down and focus on a particular tile on the screen in front of you. Today, as part of the FinOps portfolio, we're really going to focus in on that workload optimization tile. Now, we've touched each of these and each contribute to a different level of spend and risk management within the platform. But our goal really now is to really look at holistically, what does that FinOps portfolio really look like? So this is probably one of the first times I brought up this slide during these sessions, but what we have here is different capabilities that we have already brought to market, and today something that we are bringing to market fits in nicely with this broader FinOps portfolio. We need to expand and look beyond just the traditional capabilities of compute storage, network, and optimizing spend in those particular areas. So as the market and as technology has got more complex and more of our workloads are being put into the cloud, we've obviously need to expand what we're doing. So whether that's from the GreenOps perspective and sustainability, whether we start to look at the software licensing side around, what bring your own license scheme in whether it's AWS or Azure, and how can we optimize spend in those areas. Then we start to look into the more of the emerging areas in FinOps, and rate optimization being a massive one of those. So looking at your commitments and discounts and other things, spot instance management as well. So really leveraging the power of going to spot marketplace, procuring spot instances to run up workloads that are significantly cheaper than your traditional on-demand compute. And then today is really where we want to focus our time on workload optimization. Now, there are a few different concepts in this space. If I start to look at right sizing and bin packing being the two key ones from our Ocean technology, moving into the auto scaling side of that, and then into the topic of today. So how do we look at data cloud optimization with the same lens of FinOps, looking at it from the lens of visibility and spend and risk management in this space? And today we're going to go through what that is and education around that, because it is quite a different concept to what traditional FinOps practitioners may look at, and especially so for the ITAM folk that may be on this call as well. Now, to start really basic, as part of the research for this particular webinar, we spent a bit of time going into looking at the market and what the market was telling us. Now, obviously, I think most people on this call would have seen Snowflake or Databricks at different times, different events, they're marketing, they're big in the market. And what we're really looking at is the collection of these things, and particularly these 5, which were really classified as your tier 1 data cloud platforms, and then depending on what research you may look at there, but these are the 5 prominent ones that are being used in the market today. The key for these is that we've moved away from having the separate and disparate compute, storage, networking that was on-premise. If you looked at your traditional data warehouses. So we want to categorize the data cloud platform, and these are cloud native versions of those things. And in some cases, that the ingestion, the storage management, the analysis of that data is also built into the same as a service model. You don't get the responsibility of managing all those individual components and parts and doing away with those. Databricks is a little bit of an exception to that, and that's where we want to dig a little bit deeper today. The market itself is also growing. So it depends once again on what research and the background in this space, but there's roughly between 10 and 15 different data cloud platforms in 2025. As we moved into this year, we can see about 20 to 30 different platforms in this space. So it's a growing space, much like AI is growing. I think data cloud is also growing at a very similar pace. And this is for 3 key reasons, or 3 trends really. It's lakehouse architecture, which is prominent in these areas. The need for real-time analytics engines, which these platforms provide. And also with the AI trend explosion uptake is having AI native data platforms. So a couple of examples here were Pinecone and LanceDB. Now, the key to all of this as well is, if I look at the traditional research and the fantastic state of cloud report in this instance, data warehouse solutions capabilities are actually in use by 74% of people that responded to this survey. So this is why it's critically important that we also look to this to see how we can manage this spend. On the other side, if I start to look at what becomes the responsibility of those FinOps teams to manage, and this is that next level down view, and this is from our State of ITAM report, is that data cloud platforms are becoming so roughly about, I think it's on this one was about 35 to 38% are already managing those platforms today as part of FinOps. So you can see here that it's critical outside of the traditional Azure, AWSs, GCPs, and other CSPs and out there, these data cloud platforms are becoming the responsibility of those teams as well. And over the next 12 months, this is only going to increase. So this is this green on the end there. So this is what those FinOps practitioners are expected to manage in that next 12 months. Close to 70% believe that they'll be managing these platforms. So we need to be proactive and we need to understand this space better to fully grasp, the concepts around visibility and optimization in data cloud. Now, when we start to take a look at this, and this is where we get into the detail around, why do data clouds get out of control? So now we're going to focus a bit more on Databricks and Snowflake. They're the hot topics at the moment, but really, these are the platforms that rely on elastic, consumption-based compute, creating visibility, allocation, and cost control gaps. So we start to talk about visibility. This is where we start to look at this complex currency management. So each of these platforms have different ways in which they will, you consume tokens, credits and DBUs in this case, but the consumption mechanism is completely different from traditional cloud. Often there'll be decoupled, storage and compute, and we want to get down to a different visibility level. So in Databricks, for example, that workload level granularity, we want to understand what's happening just beneath the surface. Now, allocation becomes a problem because we're bringing in novel concepts, whether it's warehouses or clusters. These are shared resources a lot of the time across multiple different business functions or services. One team's performance may affect another team's cost. So if there's a long-running job that exists out there or a query that has no boundaries or guardrails, that may affect the cost of everyone. So how do you allocate cost for one team consuming more than the other? So you need those usage inputs as well to help with allocation in a traditional FinOps sense. And then we start to look at predictability again. So, it's similar to most of the demand on workloads in the cloud, but on-demand compute causes spikes. So if we have parallel, jobs being run, spinning up additional clusters with different, workers and nodes out there that expand the ability for, to process a particular job or a run or a workload, these things can explode depending on the guardrails that have been set, and which has a massive impact on cost. And it's very difficult to forecast spend. And this is where, visibility leading to allocation, leading to predictability. And inefficiencies are different again. So these are very different from traditional, compute and idle compute instances. We start to talk more around idle warehouses and clusters and different concepts that we're traditionally used to. So we need to understand these concepts, what contributes to being used and not used in this space, what's been over provisioned in terms of how these data clouds are using those particular workloads in Databricks. Once again, a little bit different, using the compute in the back end as in classic mode, and inefficient queries. So, we're sending particular queries, whether it's, batch queries that are happening, jobs that are running at night. These inefficient and long-running jobs that are using more compute power, more DBUs. How do we actually optimize those queries to help reduce costs as well? So what we wanted to do quickly is just compare the two, because we just spoke a little bit about some of the distinctions between both Snowflake and Databricks there. But really, when we start to look at Snowflake, it's a managed service with three main layers, storage, compute, and cloud. And usually you pay for all of those in their credit scheme. Databricks is unifying data analytics and the AI platform built around the lakehouse model. So there's a lakehouse, there's a Delta engine that sits on top of that, and that's how you query the data and run the queries on top of that. On the Snowflake side, on-demand or capacity commitments. Databricks, we bring in the terminology around consumption by workloads or services, often mixed with cloud infrastructure changes. Snowflake, we focus more on queries and MLs to run on the virtual warehouses, which can be resized or configured independently from storage. Databricks focuses more on the differences between serverless, classic compute, clusters and nodes, and then SQL warehouses. Snowflake's will bill for warehouse compute is per second with a 60-second minimum each start, and changing the addition of the service that you're running in Snowflake will then change the unit economics, so the price per job, run, query, that sort of thing. Where Databricks, we focus on workload and service type and the compute mode that changes the unit economics. So whether we use in standard or enterprise edition in Databricks can change the DBU costs. Even if we're using like a classic or serverless, changes those as well. Now, the way that we liken this is where Snowflake is more closely aligned to how SaaS operates. And where we're consuming credits, we don't really care too much about the underlying infrastructure here. Databricks, is more aligned with PaaS. So there are elements of traditional IaaS in there. We still care about some of the compute in classic mode, but what we're consuming at the end of the day is Databricks units. Now, when we start to talk about the traditional FinOps, Azure right down one end of this is where we say, VM right sizing, storage tiering, reservations, idle resource cleanup, tagging, chargeback, and those elements. There's a little bit of truth in that those are relevant in classic mode in Databricks, but in Snowflake, it's not. So Snowflake really looks at consumption governance, workload engineering, and really about the commercial commitment alignment. Databricks is a mix of both, and that's where we place it sort of on the scale here, but sort of between PaaS and IaaS, depending on the service that you're consuming. Now, to take that example a little further, and this is where we start to look at, this is a very simplistic diagram. So where we start to talk about how do we look at optimizing Databricks. So we start to look at the DBU pricing. Initially, we work at the workload or, the service families. So in this case, we're going to use an example next on Lakeflow jobs. Whether it's Lakeflow or it's SQL warehouses, you look at the service that you need or the workload that you need, and then look at the options that you have on the right side here. So whether that's a serverless option, where the DBU cost is, including both the workload and the theoretical compute that sits behind the scenes, or a classic option where you've got to then go and pay separately for the AWS, Azure, or GCP costs. And each of those, cloud providers, the instance types that you choose, the regions that you choose, all have an impact on your cost, separate to the DBU cost of your Databricks consumption. Now, a lot of this is different ways as well to look at optimize and spend in this space. So decide whether you're optimizing platform spend, cloud spend, or total cost. So part of the big trap here inside of Databricks classic compute, you may reduce those Databricks units, the DBUs, but you may inadvertently increase the cost of your cloud, VM cost, network storage, those types of services. So Databricks itself has been trying to push people to the serverless options to have better control over those spends and a bit more predictability around those spends as well. But keep that in mind. If for a classic mode, you need to consider both the VM, public cloud costs separate to your DBU costs. Go through the exercise of mapping your workloads to compute modes. So classify if it's a scheduled job, if it's a SQL BI job, interactive notebooks, your machine learning AI pipelines or serving, and then ask, do each of these need to be on serverless, classic, or a SQL warehouse? So depending on the particular workload, they'll support one of the three. So depending, Databricks supports multiple different modes here, different warehouse types, and each has different economics. And an example of those, economic options is on that graphic in the bottom right-hand corner there. The next stage is to build DBU visibility by SKU and by workload. So understand all the concepts together is about having visibility to do that. So there's the system billing tables in Databricks to monitor that usage and cost, including workload and serverless usage analysis. But it's also good at looking at tooling that can support this particular visibility. Number 4 here, so right size classic compute, but don't over apply VM error instincts. So we're not going to go too hard on overly optimizing because it may impact performance of the Databricks environment. So for classic clusters, so normal cloud tuning still matters. So node family, auto scaling, runtime selection, and job design. But it's an opportunity to consider serverless. So it removes much of the burden of the configuration and overhead in the background. And finally, optimize the workload service pairing. So Databricks pricing varies by the workload family. So basically, a poor architectural choice can lead to a licensing issue in disguise. For example, something running as always on interactive workload, where it could be just run as a scheduled, nightly job or a SQL warehouse, can materially change your costs. So you've got to be aware of that particular workload and service that you're running, fit them with the right infrastructure to support that can help reduce cost but keep the same level of performance. Now, diving into one of those examples that I was just mentioning with Lakeflow Classic Jobs. So I just picked this one at random and just to sort of give you the different scenarios on optimization. And let's look at 3 different versions of how to run Lakeflow Classic Jobs in classic or serverless mode. So we start to look at scenario A here. This is where we have a classic optimized workload. This is where you've got tightly controlled compute. So if I look at my DBU costs, 5 nodes by 2 hours for the job runtime, it's $1.50. The AWS compute that sits in the background for the same size would be roughly $1.92. And then the total runtime per day, because you're only running it during that 2-hour window, is $3.42. So over the course of a year, it's $1,248. Now, if I look at scenario B, this is where I have my idle cluster. And I've left my compute running for the whole day for 24 hours a day, but I only need to consume that for the 2 hours that was run. Now, as you can see, the economics of this changes drastically to up to just over $41 a day. The DBUs, get impacted because they're running at the same time, potentially that idle resource is running, but the AWS cost is the significant impact here. So this is where $23 just for compute adds up to close to $15,000 in a year. So, scenario A is 10% of the cost of scenario B because we've right-sized the compute resourcing. Scenario C is when we start to look at the serverless options. So we're only going to use a service when we need it. We're paying for the DBU cost of the 5 nodes for the 2 hours to run that job and process the Lakeflow job at night and process that once. That's going to cost $3.50 in total. So you can see the differences between scenario A and C here. The DBU cost is higher, but that's because I'm not paying for my AWS costs. So the net results basically over the course of a year is inconsequential. It's about $30 different. But then this is impacted by the, obviously where, classic compute gives you a lowest possible cost when infrastructure is perfectly optimized. And then serverless, when you have that predictability about when you need to run serverless. And this is where down the bottom here, we've just sort of given some indications where best to use it, but also as well some other considerations. So looking at cluster idle times, startup times. So Now, if you've got in scenario A, using classic, spinning up that resource could take 3 to 8 minutes to spin up the resource. Looking at workload runtimes and retries. So if you've got a poorly, executed, defined SQL job that's taking an hour where it should take 30 minutes, you may want to optimize the code that's running then to reduce the time that it takes, thus reducing the cost, and retries as well. So it's important to have guardrails on those jobs and queries, so that if it fails, does it retry indefinitely? Each of those retries adds to the cost. So it's important then to put the guardrails on that to ensure that it tries 2 or 3 times and then fails out, and then you can have an opportunity to fix that. All right, so just Danny's just going to quickly cover some details about the FinOps side.
Excellent, thank you, Nathan. So I guess from a FinOps practitioner point of view, and what I've heard our customers saying is that we're looking for KPIs. What does that mean? How do we measure it, and what's the value behind it? So fortunately for us, we understand the workloads that are happening. We understand the value that's there. We can understand the commitment utilization, being able to say, yeah, we can burn down your tokens and your utilization, whatever is there. It's very similar to an AI scenario where you're consuming something that is different to CPU memory for a lot of it, but there's definitely a cost associated, and then there's sudden cost spikes that are associated to that too. We do understand that this also fits into the FinOps technology category, so it's not necessarily a scope by itself. I classify this more around the cloud scope. So what you're connecting, it is a data cloud. We're able to see what is being consumed, who's consuming it, how it's being consumed, and then to allocate those costs as well. What we want to do and what we need to achieve as a FinOps practitioner is say, we know that team A uses this. We have aligned and allocated those costs to you so that you're now responsible and accountable for the consumption within your data clouds, which is exactly what you're doing today within your AWS, your Azures, your GCPs, and so forth. But we're making sure that it's completely visible, it is transparent, and that you can control those costs as well. If you want to go to the next slide, Nathan. All right, so what this means from our platform and CCO is that we understand the granular costs. So we can see the credits and DBU levels, we see the breakdowns, we understand the clusters and workloads. You can now capture those and say, we know team A uses this, and you can allocate those charges. So now they see what they're using and how they're using it, but also the cost of that utilization. This feeds into budgets and forecasts, helps you to keep those workloads predictable, because you now know that over the last, say, 12 months, our ML engine has looked at your utilization, and we can see that over the next 12 months, it could potentially be here, or it could start coming down, depending on how you're using it, and also your optimization if it's in that field as well. We will be releasing optimization recommendations in this space too. The first step, obviously, for any FinOps practitioner is that visibility. That's that understanding. The second step is seeing where you can get better value from your data clouds or any cloud in general. And then once you have that control, you can configure your anomalies as well. We will automatically pick up anomalies and spikes in cost. So that way you can manage those, because a lot of the time they're unexpected, thus an anomaly, but it helps you to track what it is. And it could be a failing job that just continues to retry. We want to make sure that they're picked up quickly, so that way you don't get a bill at the end of the month, which is what a lot of customers get. And they say, how come our data warehouse, how come our Snowflake costs have spiked? And traditionally with, say, Snowflake, for example, I've spoken to a couple of customers around this. All they have is a line item in their AWS marketplace saying Snowflake, X amount of $1 million for the next 12 months. And that's the complete breakdown and visibility they have today. So we're trying to move that to being aligned with what AWS and Azure can provide you right now.
Perfect. And just to highlight as well, so these are capabilities we're bringing to market across the course of this year. So please do keep an eye out on announcements around the space when we do release the Databricks capabilities starting first. So over the next few months, there'll be more information available. We just want to highlight this side. This is from some of the case studies from the capability that we have acquired. And just want to show some real world examples here of where customers are actually achieving those goals that we want to bring to market as well as part of our FinOps capability within our platform today. So some really good opportunity to save costs, even on here, anywhere between 15 to 30% of those costs as well. And finally, I just want a preview of what's to come in terms of the capabilities in the platform. So Danny, just to wrap it up from your end.
Yeah, sure. So from a visibility perspective, this is our standard tabular view, but it'll give you a good breakdown of the jobs, the workloads, the workers, the warehouses, etc. that you have. So you can see the what, who, what, where, when, and how with the dollar values associated. We'll do the same for Snowflake as well. There is going to be also dashboards that sit behind this. So this is one view. The other view will be around, what SKUs you're using, what warehouses you're using, how is it being built, etc. So all that will be coming into the platform. So that way you can have a holistic view of visibility, exactly as what you'd expect from the current public cloud providers, just in your data warehouse or data clouds.
Yeah, exactly. Perfect. Thanks for that, Danny. And for anyone joining the call that wants to know a bit more information about what's coming, when to expect some of this capability to solve challenges within your environments across, particularly around Databricks to start with, please do feel free to connect with me and reach out. I'm happy to get you involved and on that journey as things become available for market, for testing as part of different deployment stages. Happy to get you involved and let you know when those capabilities are ready for you and to get you involved in this program. Fantastic. Thanks everyone for joining today. Thanks, Danny, for bringing us home there at the end. And if you want to know more, please reach out. Otherwise, we'll see you next month for the IBM Audit Readiness webinar. Thanks, everybody.
Thank you.